In example 5, again, we're given the graph of the derivative, and we're asked when does f have a local max. We know the local max occurs when the derivative changes from positive to negative, and that will occur only at this spot, so it occurs when x is equal to 1. For number 6, we're given the graph of a twice differentiable function f in this picture right here. Which of the following is true? And we have to order f of 1, f prime of 1, and f double prime of 1. Well, we can see very clearly from the graph that f of 1 is equal to 0. We can also see very clearly from the graph the function is strictly increasing. All right, so f is increasing, which means that f prime is positive. And we can also see from the graph that f is strictly concave down. All right, so if f is concave down, that means that our derivative of our second derivative, will be negative. So we have a negative second derivative, but a positive first derivative, which means that f double prime is going to be less than f of 1, which is going to be, I should put a 1 right there, which will be less than f of 1. All right, positive is bigger than 0, is bigger than a negative number. So we want double prime, and then regular function, and then single prime. So double prime, regular function, single prime, our answer is D. Then we get to one that's a little more challenging. I don't know if you'll see anything this challenging on the exam, but this is still a good one to get used to. We have f being defined as the sine of x plus the cosine of x, and that's only for x being between 0 and 2 pi. And the question is, what is the x coordinate of the point of inflection where f changes from concave down to concave up? All right, so in other words, we are looking for when f double prime changes from negative, all right, because concave down means a negative second derivative, to positive. So we're looking to do a concavity test. But first we got to find our values. Now we can see from our values that it looks like everything's going to be an over 4 here. We have pi over 4 all the way to 9 pi over 4. Now 9 pi over 4 that's 2 1/4 pi. Our domain only goes up to 2 pi, so that one's definitely out. So our answer is one of these 4. But we got to figure out when the second derivative changes sign. So let's go ahead and do our second derivative. Before we can do that, we need our first derivative. All right, so the derivative of sine is cosine, and the derivative of cosine is negative sine. So there's our first derivative. Now we can find our second derivative. The derivative of cosine is negative sine, and the derivative of sine is cosine. So we're interested when this second derivative is equal to 0. All right, so what we're looking at here is quite complicated, trying to figure out what values this might work with. Perhaps if we change things up just slightly. What if we were to add cosine to both sides? So we end up having cosine x is equal to the opposite of the sine of x. Now the reason why I did this is because going back to our trig signs, if you remember your mnemonic of all seniors take calculus, all right, we see that in the first quadrant, all right, between 0 and pi over 2, both sine and cosine are positive, which would not match right here, where we want cosine to be positive and sine to be negative. Or basically, we want them to be opposites of each other. Okay, so that doesn't work here. In this situation right here, only sine is positive, which means cosine is negative. This would actually work out, because if sine is positive, then we negate it, and we get a negative cosine value. So this is one situation which is good. Here, tangent is positive only, but sine and cosine are both negative. That doesn't match with what we have here. And then again, cosine is positive, sine is negative, so that's our other situation. So we want quadrant 2 and quadrant 4. Now, which of these values fall into those areas? Well, quadrant 1, that's pi over 4. Quadrant 2 is 3 pi over 4. Quadrant 3 is 5 pi over 4. And quadrant 4 is 7 pi over 4. So our answer is either going to be pi over 4 or 7 pi over 4. Excuse me, 3 pi over 4. That's this one, 3 pi over 4. Or 7 pi over 4, which is this one right here. The others are out. So you're out and you're out. So now, here we go. We have 3 pi over 4. And we have 7 pi over 4. All right, so what's a number in between? Well, pi is in between them, so let's use a test value of pi. All right, if we plug pi into the second derivative, we have the sine of pi. Well, sine of pi is 0, so that would stay there. And then we'd have the cosine of pi. The cosine of pi is negative 1, so we're subtracting negative 1. 0 minus negative 1 is a positive. We want when the second derivative changes from negative to positive, so my guess is that we're going to be negative right here, so we're going to change from negative to positive, but let's check that out. We need a number prior to 3 pi over 4. So why don't we just pick 0? 0 is in our domain, and it's a number to the left of 3 pi over 4. What happens when we plug 0 into the second derivative? Sine of 0 is 0, minus the cosine of 0, which is 1. 0 minus 1 is negative. So we have the spot where the second derivative changes from negative to positive, and it's at 3 pi over 4, so that is our answer.